If you're watching this video, it must mean you have a question about this expression, 15 minus x quantity squared. That comes from dividing our base into two pieces, such as x, and then 15 minus x, because we were told that the whole base had a length of 15 feet. Okay, so how are we going to handle this situation since we have to create an equation and we have to know how to handle this piece? Let's start slow. What if we had a square? And we know the area of a square is one side times its other side, length times width. We say side times side because in a square, both the length and the width have to be the same value. Okay, so we know this area becomes 4 times 4, or 16. Let's look at it a little bit differently. Say we have the same square, but now we're saying we have 3 plus 1, which means then that this side would be 3 plus 1 also. Okay, well, it's still the same square, but now we're going to divide it into 4 regions. This region being length of 3 times width of 3, or 9. Let's say 3 times 3. Okay. This section has a length of 1 and a width of 3. Okay, so we know that that's 3. This is also a length of 3, a width of 1, or 3. And finally, this chunk is a length of 1, a width of 1, or 1. We know this was 16. Are we still okay? 9 plus 3 plus 3 plus 1, sure, that's 16. Okay. So let's pretend now that we do not know something about this square. Let's say that we do not know this chunk. Okay, we can call it x. X plus 1. Now we're going to go ahead and we're going to label these pieces again in the same way. This chunk is a length of x, a width of x. So x times x. I'll use a dot rather than another x symbol. Okay, we have a convention where we say x times x can be written as x to the second power. Over here we have 1 times x, or 1x. In this section again, x times 1, or 1x. And finally, 1 times 1, or 1. And if we peel this off, we'll have x squared plus 1x plus 1x plus 1. And conventions say that we should clean this up. These are both x expressions. I have 1x here, I have another x. Let's put them together so that we show that we have 2 of them. That's that section right there. So let's back up and look at this algebraically. We know over here that this was side times side. So here we have the same thing going on. We have side times side. And when we're done with this expression, we hopefully will have this. It's called distributing. I need to look at the fact that there's 2 pieces in this grouping. There's 2 pieces in this grouping. Sadly, I don't know what this is, so I cannot combine these and simply just multiply this times this. Remember, when they're mashed together like this, there's this multiplication going on in between. Now, in this particular bracketed section, I have an x, and I need to multiply it by each piece in the back part. So it's going to be x times x, which is this chunk right here, or x squared. So we could think of this as length times width. The other chunk here is x times 1, or 1x. All right? Now, we finished up with this piece. We gave it to each piece in the second bracket. So let's go over to 1. 1 times x is 1x, and 1 times 1 is 1. And now we can see that we do have this expression back. It's x squared. Put these together to get our 2x plus 1. And now I want to show you one more thing. This situation, this model of our square, can be thought of algebraically as this, and we can take it one more step and look at this as x plus 1 times x plus 1. X plus 1 times x plus 1 could be written as the quantity x plus 1 to the second power, because the exponent tells us that we're going to see the whole base times itself again. So good luck continuing with Leslie's fertile flowers. I hope this helped.